pipe dream began in Roma, 320 miles west of Brisbane. Here, for millions of years, nature camouflaged a secret. Once lizard and emu ran unhindered. Then settlers battled floods and drought, and the earth yielded some of her wealth. Roma district became a flourishing grazing centre, with fat cattle fetching top prices. Crops forced greater concessions from the earth. A profitable wine industry, but only surface bounty. Other rewards waited to be uncovered. At the turn of the century came a new breed, the oil seekers. Despite many failures, hope survived. In 1954, Associated Australian Oilfields, with better equipment and more scientific knowledge, made their first significant strike. In 1961, the Associated Group laid Australia's first natural gas pipeline to Roma Powerhouse. By 1964, the new fuel was generating power for neighbouring towns and farms as well. Roma Hospital also benefited, converting coal-fired boilers to use natural gas. More economical, cleaner than the smoky stacks of yesterday. Australia's first town to use natural gas was a step to progress. Even a gas barbecue for picnickers. Roma became the centre of the most active drilling program in Australia's history. New fields and increased reserves made feasible a gas pipeline to Brisbane. But outside help was needed. The Southern Union Gas Company of Dallas, Texas, with years of experience, joined the Australian Associated Group. A jointly owned company, Associated Pipelines, was formed to undertake Australia's first major natural gas pipeline. A new industry based on natural gas was attracted to Brisbane, justifying the $10 million line. After aerial survey, ground survey parties pegged the line. Property owners were adequately compensated for right-of-way. Fences were opened for heavy machinery over easement strips up to 50 feet wide. In January 1968, Australia's biggest construction company, Thiess Brothers, won the $3 million contract to lay the line. Heavy machines roared into action, clearing a long swathe through the bushland. Rugged terrain posed problems, but for every obstacle, man's ingenuity had an answer. Stubborn, rocky ground was ripped and eventually conquered. In tough going, backhoes gouged a protective trench 3.5 feet deep. In easier ground, wheel-type ditching machines chewed out the trench, sometimes more than 3 miles a day. Under another $3 million contract, road transport brought steel pipes from tube makers of Australia. 14,000 tons of them. They were laid on the line near the ditch. The 10 3/4 inch diameter piping was thin-walled, but could withstand pressures over 1,200 pounds per square inch. Strength to carry up to 50 million cubic feet a day to Brisbane. A stringing operation laid the pipe along the route. Over the Great Dividing Range, progress was sometimes slow. The descent near Toowoomba was tough going. Wet weather occasionally added new problems, but the line pushed steadily forward. On the plains, the going was easier. But always new obstacles. Creeks and rivers had to be crossed, and pipes must fit ground contours. Powerful machines bent the pipes to carefully calculated angles. This time, the pipe had to be bent to pass under a creek. The water was dammed back to allow the trench walls to remain intact until the pipe was laid. Lengths were lined up and joins securely clamped for welding, the most important part of construction. Welding is the key to a sound job. Any pipeline, gas or otherwise, is only as strong as its weakest joint. In favourable conditions, a good team would complete up to 300 welds a day. After each weld, the joints were thoroughly cleaned and buffed. The firing line moved steadily along the 272-mile stretch to Brisbane. They made 42,000 welds. The welding operation was carried out in 3 phases, using an electric arc to melt and fuse the metal to the pipe joint. The electrodes were coated with a substance to reduce oxidization and form a shield of slag at the weld. First, a stringer bead weld. Then, grinding. Then an intermediate, followed by a final capping weld. Every day, a fresh challenge in laying the pipeline through rough terrain. X-ray equipment was needed to detect possible minute flaws. The critical importance of every weld demanded thorough examination. Visual inspection would find some flaws, but not all. On the X-ray film, however, any faults were plainly visible. There's only one way to treat a reject joint. The entire joint has to be cut away and the job re-welded. A special bevel cutting machine removed the reject section. Then the ends of the pipes had to be cleaned again and clamped together to take the new weld. With long hours and pressure to speed construction, smoko was always a welcome breather. Tankers constantly supplied the fuel-thirsty project. Mobile camps housed the workforce. The cooks knew how to cater for hungry men, and there were few complaints. To keep pace with the job, all camp facilities were designed for easy moving to new sites. Most of the workmen depended on the company for accommodation. Others had their own caravans. The actual laying of the line was continuous. Side boom tractors lifted the pipe from skids, and a self-propelled cleaning and priming machine did a thorough job with rotating brushes and buffs. Then a coating and wrapping machine gave the pipe a protective covering before it was lowered in the trench. The wrapping used was a polyethylene insulating tape, followed by a laminated kraft paper. Like a giant bandage, it was wound round the pipe. Insulation was tested with an electric detector. It signaled instantly if 15,000 volts made contact through the tiniest flaw in the wrapping. As the pipe was lowered into its permanent bed, an angle dozer partially filled the trench. The soft earth from the first fill was compacted by a grader. To prevent corrosion in years to come, a cathodic protection system was installed. The wheels of the tractor then completed the backfilling. Blasting was necessary at the Bremer River crossing. Then a drag line took over the job and gouged out a trench about 6 feet deep. Here, sophisticated machinery was of little use. Wrapping and insulation had to be done by hand. After extra protection to preserve the pipe underwater, concrete weights were fitted to hold the pipe down on the river bottom. A special tie-in crew worked on the river crossing, while the line continued towards Brisbane. The length of pipe needed was computed, and that section became a project on its own. With extra care, the section was inched towards the river. More welding. The joints had to be perfect before being submerged. A team of skin divers worked in close cooperation with the land crews. They examined the riverbed to ensure the trench was clear and ready to take the pipeline. A final inspection and launching signal. Fortunately, the Bremer has little current. At slack tide, the pipes were floated across and carefully lowered into the trench. Roads were another obstacle. As the line neared Brisbane, there could be no question of delaying the heavier traffic. A ditch digger worked as close as possible to the road shoulder, then the tie-in crew took over again. A boring machine added variety to the equipment. For a perfect fit, casing was fed through as the hole progressed. The 15-inch bit bored through the hard ground under the roadway without disturbing the surface. And added protection, spacers to keep the pipe centrally located in the casing. Then, lowered into the trench, the pipe was fed carefully into the casing, where the spacers prevented electrolytic leakages. Railways presented a similar problem and were treated in the same way. At no stage in the construction of the entire pipeline was traffic halted or seriously impeded. Neither was the work on the line slowed to any great extent. As the tie-in crews worked on road and railway crossings, the excavation, laying and welding continued on the other side of the obstacle. Again, all wrapping and insulation had to be done by hand. Near Goodna, a regulating station was installed and the first feeder lines to bring gas to local industries were laid. The regulators reduced the pressure of the gas before it entered the final section of the route, where the line was increased to 12 3/4 inches in diameter. Associated Pipeline's own specialist inspectors checked the job continuously. Frequent Department of Mines inspections ensured the highest safety standards during construction and a safe pipeline for the future. Meanwhile, other crews restored the land. The line was pushed through Brisbane suburbs to Gibson Island. Then came a series of tests. A cleaning pig was run through the pipes and water was pumped in. A pressure exceeding 1,000 pounds per square inch was built up and maintained for 48 hours. The line held and the water was released. It was purged from the pipeline with rubber spheres and later a squeegee pig. At Wacol, the Department of Industrial Development has established a major industrial estate. Here, a feeder line was installed by the South Brisbane Gas Company. Closer to Brisbane, a fleet of conversion vans was visiting every home serviced by the gas company and making necessary adjustments to all gas appliances. A small army of trained men minimized delay in domestic conversion. At Roma, all was ready. Gathering systems were checked. A compression system was not necessary to force the gas along the line. Flowing pressures from the welds were high enough to ensure adequate supplies at the Brisbane end. Then the official opening ceremony. The ceremony near Roma, which sent the gas on its long 272-mile journey to Brisbane, was performed by the Premier, Mr. Bielke Peterson. The achievement reflected credit on all concerned, and he was quick to acknowledge the fact. As he opened the valve, the gas pressurized the pipeline. Under normal conditions, it would travel the full length in about 3 days. At Goodna, the first commercial area to receive the gas, its coming was marked by a flame from a waste pipe. Then at Mount Gravatt, a spectacular flare signalled the arrival of natural gas in Brisbane. The occasion was fittingly celebrated. For Associated Pipeline's chairman, Mr. Avery, it was a triumph.
But Brisbane, I believe, is the first capital city to receive bulk natural gas through a main pipeline system.
He was congratulated by the Premier.
Now I have very much pleasure indeed and consider it a great privilege of declaring open the Brisbane end of the natural gas pipeline and announce the arrival of natural gas in Brisbane. Thank you.
To mark the achievement, Mr. Bailey, Vice President of Southern Union Gas, presented the Premier with a set of gas candles. The Federal Minister for National Development, Mr. Fairbairn, added the Commonwealth Government's congratulations. Later, at Mount Gravatt, Mines Minister Mr. Cam lit the stove in the first home to receive natural gas. Meanwhile, the Minister for Industrial Development, Mr. Campbell, started the wheels of industry with the new fuel at Rochdale. His department had done much for the success of the overall project. It had facilitated its financing and assisted in creating a market. The Roma to Brisbane Pipeline had been a combined operation. The associated group conceived the plan, Southern Union Gas supplied the technical experience, and Tees Brothers proved that Australians could handle a job of this magnitude. A success story beginning in frustration and failure. A pipe dream of imagination brought to fruition by perseverance and cooperative effort.